How's it going, everybody? And welcome back to our Cisco Enterprise series, where we're going to be focusing on EIGRP and specifically looking at adjacencies. So, what we're going to be doing in this video is focusing in on this area right here on XR43, R29, R28, and R61, and going through the configuration of getting EIGRP operational. So without any further ado, let's go ahead and dive into this whole process. So we're going to begin our discussion here with forming adjacencies with these routers here. So 28, 29, 61, 43. Now, one of the things that I'm going to go do is I'm actually going to zoom in just a little bit on this particular area so it's easier for you guys to see, first and foremost. And I'm going to pull up Secure CRT. So we're also going to do a little bit of whiteboarding as we go along so we can nail down the specifics. So there are a couple of things to keep in the back of your mind when it comes to how EIGRP forms adjacencies. The first one is going to be the network command. The network command is going to be the primary way that you do EIGRP because it's going to leverage multicast to find other EIGRP speakers and form adjacencies. You also have the neighbor command, which is going to be used for unicast communication with EIGRP in the event that there isn't an underlying multicast capability for you to leverage. Now, when you talk about adjacency, the network command is going to be the first step, but we want to really dive into how that actually works. So what I'm going to do is I'm going to walk you through the process of how that actually happens. So blue will work. So the first thing you want to do when it comes down to EIGRP is understand that the network command is designed to enable EIGRP on an interface. In other words, if I have R1 and I have R2, these guys are both hanging out doing their thing, and I have a link between the two. Let's say this is 10.1.2.0/24. I've got .1 here and I've got .2 here. What I do when I go underneath router EIGRP 1, this being the autonomous system number, is that I type in the command network 10.1.2.0.0.0.255. When I type this command in the CLI, what that's going to do on both routers, so this is going to be done here and here, what this is going to do is the EIGRP process is first going to look for which interface has that IP address 10.1.2. Well, it's going to be this one right here, and this we'll say this is gig 1 here and gig 1 there. Well, it's going to look at gig 1 and go, okay, well, I have a matching subnet. Obviously, in the fourth octet, the IP addresses aren't going to match there because they're two different devices. But either way, the first three octets match. So we have a longest match capability or we have a longest match there. So the most bits in common. What's going to end up happening is when you do that and you have matching interfaces, you're going to then, on each interface, you're going to send a hello out to 224.0.0.10, which is EIGRP's well-known link local multicast address. So that's going to be sent out this way. R2 is going to do the exact same thing. He's going to send a hello to 224.0.0.10 this way. So they're both going to send hellos out, and what they're both going to do is they're both going to see each other. And when they do that, they are going to then go, oh, well, I have an adjacency. There is another EIGRP enabled device on this layer 2 segment, and they are also willing to speak EIGRP with me. So when we go through and do that, then you're going to see EIGRP full adjacency, or whatever the actual look is. We're going to look at that here in just a moment. and you're going to go and see a full adjacency pop up. And then we'll take a look at the tables and things like that. But so that's essentially what's going to end up happening. Now, the network statement is what I want you guys to really pay attention to, because I mentioned 0.0.0.255. So what exactly is this right here? Okay, so we have our prefix, right? What is this thing called? That doesn't look like a subnet mask to me, right? Well, the opposite of a subnet mask, so a subnet mask is a wildcard mask. And what the wildcard mask is an inverted subnet. So essentially what that means is if you were to take 255.255.255.255, so the wildcard mask, if you take the 255.255.255.0 and you subtract that from it, you get a 0.0.0.255. So that is a wildcard. And this works with any subnet mask. So if you're not sure what your wildcard mask should be, even if you're looking at something like, you have to use an access list to match on a particular set of traffic, and it's going to be a subset of a /24, like a /27, you can swap out this for a 224, and you'll get your response back. What it's going to be, 224, it would be a 31, right? So you're able to use this to figure out what your wildcard masks are going to be, and you can match on whatever you'd like. So if you're dealing with a /27 as your subnet mask, you would take this, for example, get rid of this. Well, I really didn't need to do that one. Do this, and this is going to be a 224. Well, 0.0.0 dot, and then 5 minus 1 is, or 5 minus 4 is 1, 5 minus 2 is 3, 2 minus 2 is 0. So obviously it'd be a 0.0.0.31. That would be, and the 32 is the range, so that would be your range, would be a 31. So it's very, very easy to figure that out. So this is something that I use quite a bit whenever I'm, I walk through this whenever I'm talking about how a routing protocol works with the network statement. OSPF, EIGRP, and RIP all leverage the network statement. ISIS does not. ISIS, you enable the protocol at the interface level. So if you're dealing with iOS and iOS XE, this is how you configure interfaces to run the routing protocol. If you're in Nexus, you would enable the routing protocol at the interface level, and we'll take a look at Nexus as well. Once we get into the enterprise or the HQ site, we'll be taking a look at a lot at Nexus, because I think it's important for anybody that's going to be dealing with enterprise networking. You're more than likely going to see some Nexus in your career, especially if you're dealing with anything data center. And then iOS XR is more of a service provider technology or platform, but ASR 9K, you might run into it. So I'm just going to cover it anyway so that it makes sense. So that's how you figure that out. And just to recap what this means, whenever you use the network statement is going to look at the prefix, find whichever interface is running, or interfaces. You can make it a much wider. So the network statement could be 0 dot, or could be 10.0.0.0. You can make it classful, right? You can 100% do classful network statements. If you decide to do that, go ahead and do that. All you're going to do is you're going to say any interface that starts with 10, go ahead and allow it. So it's just one of those capabilities as you get further along that you'll need to make sure you detail that information out. So now that we've talked about that, and we have a solid understanding of how that comes into play, I'm going to go ahead and clear the screen. I'm going to scroll back up here to this particular section, and what I'm going to do is I'm going to pull up the CLI, and you and I are going to enable, so that I can bring this down just a touch. I'm going to go on to R28, and if we do a show IP interface brief, and if you're not sure how to configure an interface, show run interface gig 0/0, you simply would type in IP address and then the IP address you want, and then your subnet mask. After that, that's how you configure an interface. Fairly straightforward. What I'm going to do here is we are dealing with EIGRP AS2. So I'm going to type in router EIGRP question mark. Now, the top option here is the autonomous system number. It's an 8-bit or it's a 16-bit value, so you go 1 through 65535. The bottom half is going to be if you're going to want to run named mode. We're going to be covering named mode later on. Named mode changes the way that EIGRP operates. So for right now, we're just going to be running in autonomous system mode, and I'm just going to press EIGRP2. From here, I have to hit the enter key. Now I'm in my router subconfiguration mode, and I have a handful of options available to me. So if we were to look at the way that this is set up, you've got the address family, IPv4, IPv6. Do you want to auto-summarize down to the classful range? Do you want to use BFD? Do you want to use the default configurations? Do you want to advertise a default route? Do you want to set a default metric when you're doing redistribution? So you don't have to go underneath a route map to configure that. We'll talk about route maps down the road once we get into redistribution. Distance, distribute list. We'll go through a lot of these here, but if we do show run all section EIGRP, these are all the things that EIGRP are going to run out of the gate that you don't have to worry about. Timers active, 3, timers graceful restart, purge time 240 seconds, maximum hops is 100 seconds, or 100 hops. Then we have metric weights. We have our 6 weights. We have 101, so this would be bandwidth, this will be delay. Then we have traffic share balanced, a variance of 1. We have our timer distance. EIGRP internal is 90, EIGRP external is 170. No auto summary is turned off by default, so we're not going to auto summarize anywhere. No passive interface default, meaning that we're going to enable EIGRP everywhere. We're going to log neighbor changes, log neighbor warnings, and then it's I believe that's a 10% variant. We can verify any one of these things can be verified. We could even shut down EIGRP if we wanted to. So if you wanted to shut down EIGRP to take this router out of the routing calculation, you could. So what I would do is I would enable EIGRP for this interface right here, 2.28.61.0/24. So I'm going to type in network, and I'm going to type in 2.28.61.0. Now I have the option of using the wildcard bits, or I can use the enter key. Now if I do the enter key, it's going to go to this classful boundary. So do show run pipe section EIGRP. We go to the classful range, meaning that anything in the 2.0.0.0 range, 2/8, is going to be enabled for EIGRP. I don't want to do that. So I'm actually going to come back up here. I'm going to type in no, then verify that that's been gone. So if you type in no at the beginning of any statement, it's automatically going to remove it from the configuration. What I am going to do is I'm going to hit the up arrow a couple times. I'm going to press Control A to go to the beginning of the line. I'm going to go to the network, the end of network. I'm going to press Control W once and hit the enter key again. Oh, sorry, I just did it again. Well, I'm going to come over here, and then I'm going to do the 0.0.0.255. Now, if I do show run section EIGRP, you can see now that I'm matching on 2.28.61.0/24. Okay, now that I've done that, the first thing I'm going to do here, I'm going to jump out of global config, and I'm going to type in debug IP EIGRP. Actually, I want to go debug EIGRP packets. And I want to do, I'm going to hit the enter key because I want to see all the stuff that's coming across. So I want to see the updates. So as you can see right now, we are sending hellos to gig 0/0, packet length is 20. So the other thing that I'm going to do is I'm going to right click here. I'm going to go to capture on gig 0/0. So I already enabled Wireshark. I installed the the capability on the box. So I'm just waiting for Wireshark to load up. I'm going to capture on the Ethernet interface. Okay, so we see the EIGRP hello. We can look in here and we can see that the, let me scoot this guy over just a little bit. We can see that we are sending IPv4. The source is 2.28.61.28 to the link local well-known multicast address of 224.00.10, and then Cisco EIGRP. We're running version 2. We can see software version we're running is 20. The autonomous system number is 2. The router ID, all that good stuff. All the information we need to have is right there. So I'm gonna let this run here. I'm gonna scoot this guy up just a little bit. That's going to reformat. I'm gonna bring this down, and I will bring this guy back up. Okay. So now what I'm gonna do is on 61. So way over here on 61, I'm gonna come over here, show IP interface brief. I can see that I have a 2.28.61.61. So I'm going to go to, for gig 1, so I'm going to type in router EIGRP question mark. I'm going to say 2 over here as well. And I'm going to type in the command network of 2.28.61.0 and then 0.0.0.255. Now you're going to see a whole bunch of stuff going back and forth. So we'll come back to that here in just a minute, where I'm waiting for it to fully do its thing. Now if I go back over here to 28, I'm going to have a whole bunch of information that just got sent back and forth. Okay. Now in the interest of time, I'm going to do this as well. This loopback address, this 2.0.0.6, I'm going to type in network of 2.0.0.6 with a wildcard of 0.0.0.0. If I do a 0.0.0.0, it means I want to match specifically on that particular IP address. So what that's going to do is we're going to see some information go back and forth. And then now that we have that information going back and forth, I'm going to come back over here to 28, and I'm going to go ahead and I'm going to say undebug all. Okay, so I want to turn off debugging, and I want to stop this Wireshark capture. So now we'll be able to go and review. So let's go all the way up to the top here. So at the top here we have hellos going out, right? Right now it says null, right? We're sending, we have the IIDB queue, database queue is, we have unreliable and reliable. So that information is going back and forth. And then we come down here a little bit, and it tells me that we have add peer total 1, and we have a neighbor change. So the adjacency will come up first, then you will go through and do your neighbor table exchange, or your topology table exchange. You'll do your topology table exchange first, and then as you can see here, the neighbor changed to up, and then we say queuing update on gig 0/0, and we have a one reliable update, sending the topology ID list on gig 0/0 1 items. Sending hello, because remember this is an active adjacency. So it's going back and forth, sending all the information you need to know, and it's going to continue to send this. So now we're going ahead, we're sending hello, and then we're also we're sending request requeued unicast update, sending update on gig 0/0. You're initializing. There's no information. You're initializing. Okay, now you've sent everything over. Now you're end of receive update. Oh, I'm sorry. If you say sending update, receive hello, received update. Sending update, received update, receiving ACK. So you received end of table, which means both routers have fully exchanged all the routing information that they have at the moment. And then you have sending topology ID list, and then, so that you've got one full one, then you do a check, and then you send another full one, is what this is telling you right here. So you have two actual full adjacency or full topology table updates that go back and forth. Received update, sending ACK, queuing ACK, sending ACK, received hello, and then by the time you're all said and done, you have all this information going back and forth. So we have all that going back and forth, and then now you're at the point where you're just sending information back and forth. You're including update. This is where if we scroll up here a little bit in the beginning, we can see that we have an ARP. Now, why do we see an ARP? Why would we see an ARP here? Actually, let me go full screen with this. Why would we see an ARP here? Let me zoom this in. And let me go a little bit out and scoot this over just a little bit. Why would we see an ARP in this whole process? Why do we see an ARP? Well, the reason why we see an ARP is because we didn't already have any communication going back and forth between R28 and R61. That is why we see an ARP. So if you don't already have communication going back and forth, you need to figure out, okay, why am I seeing this? So you say, who owns, who has, what's the MAC address for that particular endpoint? So you say, who has 228.61.28, tell 228.61.61. So router 61 goes, I don't know what the MAC address is of R28. So you go over here, and then it goes back and forth. It says, okay, 228.61.28 is at this MAC address. 228.61.61 is at this MAC address. Okay, so now you have your ARP information. So now you have a MAC to IP binding. So now that these devices can now enqueue each other. Now you go through, you have an EIGRP update. Your EIGRP update. What is this? This is going to be a new flag is a init initial set, right? Goes back. This coincides what we just saw in the debug, right? We have that going back and forth. So we have now. Notice this is unicast. There is no multicast. There's no 224.00.10. So multicast is just used to discover, right? Oh, there you are. Like, you're using a loose analogy would be like you're trying to meet somebody for the first time. You're using an app for whatever reason, and then you meet in person. Like, oh, here I am, and then it's like a hey, handshake. Typically, when you first meet somebody, unless you've known them for a little while, and you're meeting each other again, might be you might go to a hug, things like that. But 61 is talking to 28. 28 is talking to 61. 61 now is going out and doing an update. And we see end of table set and all that good stuff that goes along with it. There's really not a whole lot there. And then the update, if we come down here, we have another hello, because now at all times there's always hellos going back and forth. It's an active adjacency. So then we have a hello acknowledge, then we have another hello, then we have an update. So if we look at this, it doesn't really tell us what's in the update, if you notice that. There's really no information in the output that tells us, what was sent, right? We send a hello back. Okay. Now if we come down here a little bit further, now we can see the router ID. That's a CDP update, right? We have the more information going back and forth. Then we see another hello. Then we see an update coming from 61, because 61 now advertised a route. Now if we look at this, when you first perform the adjacency, you don't see anything. But if you do an actual route update, you send something beyond the directly connected, because you're not going to advertise a subnet that you're using to form an adjacency on. That doesn't make any sense, especially on the two directly connected routers. There's no reason to do that. But because we decided to advertise router 61's local loopback, we went ahead and since we did a network statement for that, /32 internal route, now we're seeing this. Now we see 2.0.0.6. That should be a 61, and I can update that here in a second. I don't know if I can start it over again, but I'll circle back to that. We see an update coming through, right? We see that it's a wide metric. They're set. We have our basics are set up for it. We have our bandwidth is set to, was that 8 million? So whatever that's going to come out. The delay, the MTU, the load reliability, offset priority, things like that. There's no flag set, right? Source withdrawal candidate default, things like that. So the prefix length is 32. So we see all the information we need to have. Topology 0, which means global routing table, things like that. So that's our update. We send a hello back, right? Nothing in it. We send another update. And this update basically is 228 sending back to EIGRP with, yep, I've got it. is essentially what this is. Doesn't specifically state that, but that's typically what you would see. And then you look down here at the acknowledgement. Okay, cool. I've got the routes. I've learned the route. Everybody's happy. And then you go down to your normal EIGRP hellos. So now that we've talked about that, let me go ahead and go back over here to 61. Let's see if I can actually do this inside of Wireshark. I'm curious now. Continue without saving. Okay. That's what I thought. So let me go ahead and move this down just a little bit. Minimize. So I have to, because it thinks I'm on my local computer. So let me go ahead and close this out. Let me go back over here to 28, capture on gig 0/0. And then I'm going to go back over here on 61. And instead of doing, so interface loopback 0, IP address here will be, and let me come back over here, go OK. The will be 2.0.0.61/32. Okay, so now if you look at this, so now we won't actually, if I do show IP EIGRP int, right, gig 1. So let me go back over here to this IP address, put that back, right? If I do this, you'll see loopback 0 is got a peer, or sorry, it's enabled interface. But the moment I change the IP address to this IP, and then I do a show IP EIGRP, now you'll notice that loopback 0 goes away. So instead of doing that, the IP address is now set. What I will have to do now, do show run pipe section EIGRP, is I need to update the network statement. So router EIGRP 2, I'll type in no, pull this out. So you just double click right here, or you can just do this. Let me exit out of here. I'll show you a CCIE pro tip. Highlight all the things that you care about. Go to the last line that you want to edit, copy and paste that in. Control A, type in no, and so we'll then hit the up arrow. I'll go to the beginning of the line, pull the no out, and then I'll go down here and I'll do a 61 instead. So then we'll see an update. And then if we expand EIGRP, we'll get an internal route of 61. And that's how that'll work. You see how that comes into play. Router ID is 2.0.0.6. Everybody's happy. But that's how you would make an adjustment there. So if I do show IP EIGRP interfaces, now loopback 0 is applied again, and we're in good shape. That, ladies and gentlemen, is how you do adjacencies. It's fairly straightforward and doesn't take a whole lot more to do. So now that we've gone over this, what I'm going to go do now, we're at a half hour. So we've seen Wireshark, we've seen the debug, everybody's happy. I'm going to stop this video and I am going to start a new one where we do for iOS XE. iOS XR. So I'm going to go ahead and minimize this guy. And what I'm going to do is I'll show you guys how to do it on XR. It's not very difficult at XR, but the syntax is different. So I want to have two separate videos to cover both. So we'll see exactly what that looks like. We'll go through the configuration. You know, the configuration-wise on XR it's different than iOS and iOS XE. So that's why I want to have a dedicated video for that. Once we go through that, we'll be in good shape. We'll start being able to go through all the individual pieces. We'll start verification, all that type of stuff. So until next time, guys, if you have any comments, leave a comment in the comment section down below. If you haven't already done so, please like, share, and subscribe. And I'll catch all of you in the next video.